All right, so anyways, we're looking at chapter 4. We are looking at classifying triangles. The first part, we're just reviewing things we should know. And you guys have hopefully been seeing this since elementary. So hopefully it's comes back to you guys. First one's looking at the sides of the triangle. How many sides does the triangle have? 3. Good. What's the name of this side? AB. Good. The other side is? BC. And the last one is? CA. Good. All right, let's put that into those little blanks. So we said A to B, B to C, and C to A. All right, the vertices are just the points on the triangle, the 3 corners. How many corners does it have? 3. Good. What are the name of the 3 corners? Points A, point, and point C. All right, let's go and put A, B, and C there. The first part's the review, that first little part. All right, now the angles are going to be the same as the vertices. So if you have 3 vertices, those 3 vertices are also your 3 angles. So A, B, and C are the 3 angles of my triangle. So angle A, angle B, and angle C. All right, let's look at the sides of the angles of a triangle. So we have 4 different triangles we can classify based on the angles. You have acute triangle. That means all the angles are acute. What does acute mean?
9 degrees.
Less than 90, all right? So if they're all less than 90 degrees, it has to be an acute triangle. Equiangular means all the angles are equal. Does anyone know how many angles are in a triangle?
3.
Good. How many degrees?
3.
Not 360. But get a guess. 180. All right. So it's 180. So it's 180. And if I divide the 3 angles by, if I divide 180 by 3, what would each angle have to be? 60. All right, so that is your equiangular triangle. So when they're all 60, automatically it's equiangular. Obtuse. What does it mean to be obtuse? It's more than 90. One angle would be more than 90. So the last one being a right triangle means that one angle has to be exactly 90 degrees. Okay? So we're just going to review by identifying your triangles based on the angles. So you look at the first one, example 1A, and you're going to go through your list. Are they all less than 90?
Yes.
Automatically, that becomes an acute triangle. So let's go ahead and write acute triangle. All right, look at the next one. We're going to do the same thing. Are they all less than 90?
No.
Are they all 60? No. Is one angle more than 90?
No.
Is one angle exactly 90?
Yes.
Okay, so then this is a right triangle. The only difference is that it didn't have the box for you. It had the 90 degrees. All right, look at the last one. What do you think the last one would be?
Linear.
They're all less than 90, but they're all what? 60 degrees. So this one is your equiangular triangle. Right, equiangular kind of sounds like they put equal and angles together, right? That's what it means. All right, so I'm going to give you guys a moment to try practice 1. You just have 2 to identify. All right, Mark, what'd you get for that first one? Obtuse. And Muhammad, what'd you get for the second one? Equiangular. Good. All right, so these are all based on angles. All right, if we go over to the right side of our notes, now we're going to start looking at the sides. So we only have 3 classification sides. For the sides, we have equilateral, which means 3 sides are congruent. Isosceles, 2 sides are congruent. And then scalene, no congruent sides. So if I look at example 2, how many sides are equal? 3. So is it equilateral, isosceles, or scalene? Equilateral. All right, next one, how many sides are equal? 2. So if it's only 2 equal sides, isosceles. All right, I'm going to give you 2 to try. All right, Lily, what'd you put for the first one? Isosceles. And Josiah, the last one? Scalene. Good. All right, so what we're going to do on the next one is just we're going to do both. All right, we're going to go based off the angles and the sides. All right, so first one, looking at only the angles. So you want to look at the list on the left side of your notes. Looking at the angles, 74, 74, and 32. Based on the angles, what type of triangle is it?
It is isosceles.
All right, isosceles and scalene, those are based on sides. So I want to do angles first. It's an acute. All right, now based on the sides, how many sides are equal? 2. So if it's 2 equal sides, it is isosceles. Good. So this is an acute isosceles triangle. All right, look at the next one. Based on the angles, what type of triangle? Another acute. All right, how many sides are equal? 0. So it is scalene. All right, look at the next one. Based on the angles, equal angular. And if it's equal angular, it is. All right, I'm going to tell you now, if you have one, you automatically have the other. If you have one, you automatically have the other. And the last one. What would the last one be? A right? A right triangle. But what about based on the sides? There's 2 equal, so it should be isosceles. All right, we just finished that algebra unit, so we're coming back to the geometry, okay? So let's go back to some of our definitions here. It says if point M is the midpoint of J to L, that first piece right there, if it's the midpoint of J to L, you're right, midpoint. If this is right in the middle, what should be true about these 2 sides here? They should be equal. So if this has one little tick mark, this one over here should also have 1 tick mark. And if the whole thing is 1.5, how would I figure out what each piece is? Divide it by 2. Good. So now, can y'all divide that by 2 for me? What do we get? Close, but not 1.25. 0.75. Thank you. Now, if these 2 that have 1 mark are 0.75, what could I say about this one? K to M. Since K to M has 1 tick mark, what would that measurement be? The same exact measurement, so 0.75. So these were all the measurements they were looking for. So L to M was 0.75, K to M was the same, and J to M was the same. So I'm going to put the same. That what now? Yeah, but that one's already 0.75. So since it's the same, yeah, you can add another mark there. All right, so you find all the missing side links, and it says identify the type of triangle. So the first one it wants you to identify is the triangle JMK. Look at the sides. How many are equal? All of them. So what type of triangle is it if all 3 sides are equal? Lateral. Good. You knew it was equal something, right? It's equilateral. Now, the next triangle we're looking at is triangle LMK. How many sides are equal here? 2. So what type of triangle has 2 equal sides? Isosceles. All right, if we go over to the back side, I'm going to have you guys try one. Now, keep in mind that that midpoint piece, it was important because that's what allowed me to find some missing measurements, okay? All right, let's look at practice 3. So on practice 3, it says if point E is the middle point. So because E is the middle point, what should be true about F to E and E to D? They should be equal. Now, if they're both equal, and I know the length from F to D is 11, what should we do to both sides? Divide it by 2. Good. So 11 divided by 2 is 5.5. So if this is 5.5, and this one's 5.5, and look, if you look at the image itself, this one right here that's 5.5 already has 1 tick mark. So how many tick marks should I put here? 1 as well. All right, so we found F to E was 5.5. We also found E to D, which they're not asking for. They are asking you to find B to F. What should be the length from B to F? 5.5, good. And what should be the length from C to E?
20.3.
Why 20.3?
Because it has 2 lines.
Because it has 2 lines, and if you notice this one that has 2 lines, it's already labeled as 20.3. Good. All right, so any of them that have the 1 line, I can mark as 5.5. And the one that has 2, I'm going to put 20.3. So we're going to identify or classify two triangles. So the first one we're going to classify is BFE. So here's triangle BFE. How many sides are equal?
2.
2. What type of triangle has 2 equal sides? Isosceles. Good. All right, ABF is the one over here to the left. How many equal sides does ABF have? How many equal sides does the... 3 of them. So what type of triangle has 3 equal sides? Equilateral. All right, let's get to the bottom part. So on the bottom part, it reads, find the value of D and the length of K to M of the isosceles triangle with the base of K to L and the legs of L to M congruent to K to M. So if you notice, there are no congruent marks here, but they gave you this piece of information. With that piece, you can go ahead and mark them equal. Now, when you're solving for something, the ones that are equal are the ones you should set equal, okay? So I'm going to write 12 minus D is equal to 4D minus 13. So from here, I usually move over the variable that has the smaller number. So which one's smaller, the -1 or the 4D? The -1. So I'm going to add that D over to the right side. How many D's does that give me now?
3D.
4 plus 1?
Oh, wait, right. 5D.
5. All right, so I'm going to put 5D minus 13. I'm going to bring down this 12. All right, what should I do now? Add the 13. So what's 12 plus 13? 25 equals 5D. So what should be our last step? Divide both sides by 5. So what's the D value? 5. Now K to M, it wants you to find the length. Remember, that's just substituting in. We already know what D is. We just found it was 5. So it's going to be 4 times 5 and then minus 13. So 4 times 5 minus 13. So what is 20 minus 13? 7. That's our length from K to M. All right? So anything that's equal, you just want to set them equal. Now, if you look at the last one, it's called an equilateral triangle. That means how many sides are equal? All of them. So do you think it matters which 2 I pick to solve? It doesn't. So you can pick any 2 you want, okay? I'm going to pick the 2y plus 5, because I feel like y'all would pick that one. And I also feel like y'all would pick the 3y minus 3. All right? We're going to solve for y. And again, I always move over the smaller coefficient with the variable. So I'm going to move over the 2y. What is 3y minus 2y? 1y.
Or just Y.
And then we're going to add 3 to both sides. What is y equal to here? 8. Now, it wants you to find all 3 sides. So here's my question. Do you think I have to plug it into all 3 equations?
No, you can just plug it into.
No, just plug it into the one that you find easier. So I'm going to go with the 2y plus 5. And we said our y was 8. So I'm going to go from here, the 2y plus 5. Y plus 5. So I'm going to do 2 times 8 plus 5. What's 2 times 8? 16. What's 16 plus 5? 21. So if you found one side, did you find them all?
Yes.
Yes, because it's an equilateral triangle. All of them were equal. Now, please don't rush it. I know some of you are going to get through this quickly. Last period, as I was grading them because they were turning them in, a lot of them were making silly mistakes. And it's just because they were in a hurry. I'm not rushing you guys. You guys take your time with the assignment. All right, I'm going to have you guys try the last 2, and then we'll get on with the work. All right, look at that first one. How many sides are equal? 2. Okay, so the 2 that are equal, these are the ones you're going to set equal. So if I have 4x minus 3 is equal to 2x plus 5, and I subtract the 2x, how many x's do I have left? 2. So I have 2x minus 3 equals 5. Then what am I going to do with that 3? Add the 3. So then I'm left with 2x equals 8. What would be the last step? Divided by 2, and your x has a value of 4. So you found your x. But then it asks you to find all the sides. So I'm going to plug it into this side here, the 2x plus 5. So I'm going to do 2 times 4 plus 5. What's 2 times 4? 8 plus 5 is 13. So if this side's 13, are you going to have to go through all the trouble plugging it into this one? No, because they're the same. So automatically this one's 13. Do you have to plug it into the bottom one? Yes, because that one's not the same as the other two. So what is 4 plus 2? 6. So these are your 3 answers, along with the x. Okay? Now the last one doesn't have this much work, because on the last one, how many sides are equal? All of them. So you're going to pick 2 to solve. I'm going to pick the 12x minus 22 and the 10x minus 6. All right, so I'm going to subtract 10x from both sides. And if you did use 2 different ones, that's fine. We should come out with the same number. All right, I'm going to add the 22 to both sides. So 2x gives me 16. So did y'all get 8? Yeah? No? Yes? All right. So then we have to plug it in. So you pick any one you want to plug it into. I'm going to plug it into this one here. 10 times 8. What's 10 times 8? 80. What's 80 minus 6?
74.
So if this one's 74, should they all be 74? Because they're all equal. Okay? So don't give yourself more work than you need to. Now, silly mistakes, again, silly mistakes were made last period. Like if they were dividing, they divided just by the wrong number. They did everything right. They just were such in a hurry that they just wrote down the wrong thing. Okay?